Ladies and gentlemen, mesdames et messieurs, how are you this morning? Welcome to the cabaret. Actually, that is from Cabaret when he does the open. Meine Damen und Herren. I forgot the German to begin because he begins with Meine Damen und Herren. I am Dr. Frank Summers from the Space Telescope Science Institute. We from the Office of Public Outreach are here to entertain and regale you today, and hopefully you will even learn something. But you know, that's optional because it is summertime. Our fearless leader is here today, Bonnie Eisenhammer. She is the Director of Education in the Office of Public Outreach and the person you most want to know. You can forget the rest of us. She's the one you really want to know because she has all the power up there. And she'll sit there and laugh. She's laughing at it like, oh, I have power. But, you know, what little power we have in astronomy, it's all concentrated in this wonderful woman over here. Mr. Dan McAllister, stand up and say hi.
Hey guys, you may remember us from last year. Remember Space Telescope? Oh, right.
Okay, great. How many people were here last year? All right, how many people were not here last year? That's easier. All right, we're talking to you. Okay, the rest of you I'm going to forget about. What's your name? Roxanne. Okay, this talk is entirely for Roxanne. I'm forgetting the rest of you. Okay. Where are the rest of the OPO folks? They're upstairs preparing. Okay, we have other wonderful OPO folks, much more wonderful than those of us here, who you will get to meet later. Bonnie, did you want to have any overview thing you want to say? Hi. All right. We're going to do a variety of things, solar system stuff, extrasolar planet stuff, cosmology stuff. We're going to take you from the solar system out to the deepest reaches of the universe today. All right? And we're going to do it all without microphones because what I'm going to present to you now, I need both hands for, and I can't hold the microphone close. So listen closely, watch the screens. We're going to have some fun with it. First thing we're going to do is, how many of you have seen the software called Worldwide Telescope? Perfect. We got a whole bunch of noobs. I love it. Okay, that means I can show you anything, and you won't be able to say, Frank, but there's a really cool feature that you don't know about. And I'll say, oh yeah, I thought I knew about that. All right, so on my desktop, this is my laptop, and you can see this wonderful little button right here called Worldwide Telescope. Okay, Worldwide Telescope is a free piece of software from Microsoft. And oh, wait a minute, I know what I need to do. First thing I need to do, Bonnie, is I need to go to the Virtual Observatory website. Okay, the VAO education website, virtualobservatory.org, as you can see up here. All right, this is an educational website associated with the Virtual Astronomical Observatory. And you see this tab here called Worldwide Telescope. You click on that. And we gave a seminar at the American Astronomical Society meeting in Austin, Texas in January of this year. And what I'm going to show you today is based upon that. And what you really want to know is right here. Overview of Worldwide Telescope. This is a PDF presentation that I created that has tons and tons of screenshots of everything that I'm going to show you today. It's 24 pages long in full color. Here's some of our other wonderful OPO people. Yay! As well as stuff on the other one I created was creating a tour in Worldwide Telescope, which I'm not going to discuss today. We have exploration of the solar system. Those are some good activities to do for solar system studies. We have an exploration of sky mode, some more details and stuff. We have the Texas Essential Knowledge and Skills Standards, which is not something you care about in Maryland or Pennsylvania, if that's where you're from, okay? So take down this website. This is where you can get the PDFs of what I'm going to present to you today. Now, let's go back to that beautiful blue marble on my desktop. You go to Worldwide Telescope. Actually, I could do this. It's so nice to have internet access. I'm not thinking in the mode of having internet access. Okay, so if I go to worldwidetelescope.org, this is where you would go. You can go over here and install the Windows client, or you can run the web client, okay? Worldwide Telescope has, of course, made by Microsoft Research. If it's Microsoft, what operating system is it going to run on? Windows first, right? but the programmer actually did create a what's the Silverlight client, a client using Microsoft Silverlight technology, so it can run on a Mac. All right, there are certain features that are not available on the Silverlight client that are available on the Windows client. I'm going to show you the Windows client, which is the full-featured. People will remind me when there come up some things that are not in the Silverlight client. Okay, you can download it here. You can also go to their support, and they have, they have online help if it ever loads. This happened last time, didn't it? There we go. So the Worldwide Telescope user guides and other things. You can see an essential online library of support for it, which is some of the same things that I will be showing you today, but in a different perspective. Great. Now we can go to this blue marble. We double-click it, and up pops Worldwide Telescope. We're at the Layerscape beta. There have been about 5 different versions of it. It is still considered to be in beta. All right. I said it's. Can we get the front lights in the room turned down, please? I can't see squat here. These fluorescents here are just ugly. I have control over here, maybe? Front spot. Main house. All right. Maybe if we turn the cans that are straight down on. All right, well, whatever. You guys okay with this? Cool. All right, this will show you all sorts of cool stuff. All right, as I said, it is from Microsoft, but it is free. It is a really cool program that they give away for free. All right, if you do not read any of the instructions, they know you're not going to read instructions. Programmers know nobody reads instruction manuals anymore. You have your first little instructions right here in front of you on navigating Worldwide Telescope. Okay, so you can do this is your absolute basics stuff. All right, and then you hit close. And what are you presented with? You are presented with a view of the night sky. Okay, and it's a basic planetarium program that you can spin around the night sky interactively. Okay, look around the night sky and say, hey, there's some cool stuff. You can find, okay, anybody know what this is? It's constellation Boötes or Boötes or whatever you want, however you want to pronounce it. I don't profess to actually know how some of these constellations are pronounced. How would those of you who don't recognize it note it? Well, if you look in this lower right-hand corner here, you can see, oh, it says it's the constellation of Boötes or Boötes. All right, it shows you the shape of it. Okay, it also shows you this degree here. This is degrees, minutes, seconds. It's a 60-degree field of view on the sky. You also have your celestial sphere navigation. Okay, that yellow square shows you where you're looking at the sky. If I zoom around the sky, you can see the constellation that is in focus changes, and the yellow square moves around the celestial sky. These numbers down here, right ascension and declination. RA and dec are how astronomers do longitude and latitude on the sky. All right, whereas declination 90 gets up to the North Pole. What do we see at the North Pole? Polaris, the North Star. It's 89.5 degrees north. When you try and go further north, it says you can't go any further north, so it just circles around the pole. Okay, same thing if you go down to the south. Okay. Oh, I have one of these things turned on. Hold on one second. I need to go to my view menu and turn off the field of view indicator. Right, there we go. Go back to the Explorer menu. All right. If we go down to the south, we can see that we do not have a pole star in the south. Okay. If I try and keep going south, it just spins around it. All right. Let's see. Now, there are all sorts of cool constellations out there, and you can spin around the sky and learn things. Somebody give me a constellation. Orion. That's much too easy because it's right here, already on the screen. Everyone can see the constellation of Orion here. Anybody have a constellation that they think I don't know? Oh, come on. Let's go up to the search box here, and let's search for Camelopardalis. Anybody ever heard of Camelopardalis? Camelopardalis, and let's go over here. There's the constellation of Camelopardalis. Did you guys even know there was such a thing? All right. So you'll notice what I did. I clicked on the search bar. I started typing in. I typed in camel. And I got all these stars that are in the constellation Camelopardalis as well as the constellation. You notice that it says 1 of 3 in the search results. The search results go for 3 things. If I take this down arrow here, I can see all my search results. Okay, and if there was more, it would go on this. Okay, so you can see all these various stars as well as the constellation. I'm going to bring it back up and show you what happens. This is your search bar. These are your highlights. If I click on Camelopardalis, what happens? It goes there. And wow, there is no stick figure for Camelopardalis. Wow. I mean, every other one has a stick figure. Okay, this is Cassiopeia over here. And if I bring Cassiopeia into focus, whoops. All right, you can see Cassiopeia is there, but Camelopardalis doesn't have a stick figure. I'll have to talk to Jonathan about that. All right. So anything you want to find on the sky like that can be found using this search bar here. All right. All right. We got a joke going on over here. What's going on? All right. Huh? I really don't know. I was trying to think of an obtusely named constellation, and that's the one my brain came up with. All right, but if that was all that Worldwide Telescope could do, you could go around the sky and you could learn your stars and you could learn the constellations. But is that all we want it to do? No, of course not. The cool feature of Worldwide Telescope is not just panning around the sky, it's zooming. If I take the scroll wheel on my mouse and I move forward, whoops, get that out of the way, sorry about that, random click, I can zoom in. Okay, ooh, ah, okay. I can zoom in. What the heck is this? I don't know. Let's go find out. Let's zoom in. Oh, wait a minute. Let's zoom in more. Oh, let's zoom in more. Let's zoom in more. Oh, there we go. This is the power of Worldwide Telescope, okay? We can come in and take a look in detail at these images. We can zoom out to 60-degree field of view, and we can zoom back in. All right? And obviously this is NGC 281. Okay? Cool little star cluster with some cool gaseous stuff. Anybody know what else is in Cassiopeia? Or nearby Cassiopeia? In Andromeda, actually, is the Andromeda Galaxy. And if you know how to find it, you follow the points down towards Andromeda, and there is the Andromeda Galaxy. We come in, we can see Andromeda in nice, cool detail. All right? Now, you will notice, where is all this data coming from? It can't possibly be stored on my little laptop, and it isn't. There are over 1 trillion pixels in the night sky that you can zoom into. All right? They are not all stored on your laptop. If you look in the lower right-hand corner, you can see this download bar. It is in the process of downloading the data at this resolution. So if I scan over, if I very quickly scan around the sky, I might be able to catch it. There we go. See how it's fuzzy? It will slowly resolve into clear as it downloads the data from the server. All right? Worldwide Telescope is an internet-connected application. We couldn't do this demo if we didn't have internet access in this room. All right? Now you can see it's clear. All right? If I zoom out really quickly and I pan across really quickly, things will be fuzzy, and then slowly they will clear up as it downloads data from the server. All right, so somebody give me one of their favorite objects in the night sky that they want to take a look at.
Ring Nebula.
Ring Nebula, very good. All right, I got to find my delete key here. Oops. All right, I'm working on a slanted table. It's kind of hard to keep my mouse in the correct area. All right, where we are. We're R-I-N-G. Boom, there's the Ring Nebula. All right, so we can go to the Ring Nebula. It will back out. It will pan across. And it will zoom in. Kind of cool. All right? Now, one thing you will notice is this is not the Ring Nebula as it appears in the digitized sky survey. Okay? If you look over here in the bottom left-hand corner, it says you're looking at the sky, and the imagery is the digitized sky survey in color. This I know isn't it. You can see the outlines of the image. Can you guys see that? Okay. That is actually an image overlaid on top of, oops. There's the image, there's the sky survey. Image, sky survey. It's blown out in the sky survey, so we have images. This is a second feature that I hadn't intended to go there yet, but I'll go there. Is that it's not just taking you to points in the sky, it's taking you to images of those points in the sky. So if I click on this one, this is the Hubble image, it will zoom in and show you the Hubble image. Now, like the trillion pixels of the digitized sky survey that are there for you to explore, every single pixel of the Hubble image is also there for you to explore. So as you zoom in, you will get more and more detail until you reach the limit of the Hubble image, okay? Now this one's not particularly high resolution, but if someone had said instead of the Ring Nebula, they had said Whirlpool, so I'm going to say that now, I can go to Hubble's image of the Whirlpool galaxy called Out of This Whirl in our press release, and it will go from the Ring Nebula, zoom back out. It will automatically pan across the sky. There we go. And then it says, okay, here's where the Whirlpool galaxy is, and it will zoom back in. All right, now this Hubble image is 96 million pixels. Okay, we took 6 pointings and combined them. So when I zoom in on this one, I can zoom way in. Let me take this star forming region over here, this red star forming region. I'm going to zoom in on it and keep zooming in on it and keep zooming in on it until you can see every single pixel in the Hubble image when it finishes downloading it. Okay, we can pan across and see the details of the Hubble image, and all 96 million pixels are there for you to enjoy in their visual goodness. Okay, marvelous things to explore, especially the sort of marbling of the dark dust lanes and the bright clouds, the star-forming regions, and the newborn blue star clusters. All right, really cool stuff. And what if you say, hey, wait a minute, you know what? I want to, first of all, I'm going to turn this sideways. I want to turn it this way. All right, you can spin the night sky. But wait a minute, Hubble's image is pretty good, but aren't there other images of the Whirlpool galaxy? Wouldn't it be cool to see what they are? Well, you have up here the various images, and if you mouse over them, you can go from Hubble's image to the Spitzer image. This is the view of the Whirlpool in infrared. This is visible light. This is infrared light. Notice the dark dust lanes in Hubble become the bright regions in Spitzer. If I click on this region up here, I can actually change to this. I can change to the Spitzer image. Okay. Oops. It did my rotation on me. Okay. I can also crossfade. I can take this crossfade button and go from the digitized sky survey to the Spitzer image. This is a great resource for multi-wavelength astronomy. I can also come to this image over here, called Classic Beauty, which is a combination of Hubble, Spitzer, and Chandra data all together. Now, up here is your search results, okay, having searched on Whirlpool. But you also have in the bottom, you see all these search results down here. This is contextual search. All right, whereas the upper thing shows you what you searched for by text, this is all of the things that are in the region of the sky that is currently in the field of view. So you have the same images that you searched for, okay, but you also have images like this, which is a WIFPIC 2 image of it. Let me zoom in so you can see that one. All right, we have various other and as I zoom in, everything's of the Whirlpool. But as I zoom out, okay, you will look at the geographic search in the bottom. Once it's set, will show you lots more. And I can again bring up the search for all these things, and I can say, oh, look, there's NGC 3777, one of my favorites. I have no idea what it is. But we can click on it find it. It's in the field, close enough to the field of view that it will show up. And we can find things that are nearby the Whirlpool galaxy. All right? And notice that now that it's zoomed in on that, there's not much else in the field of view. Again, I back off. And you can look at the geographic search. Once I've backed off, it will set up. It will go do a search for things in the field of view and find all those things. You can also mouse over things. And sometimes you will get, you say, what happens with this star? Is there an association? If you hover, and there is an association, it'll tell you. All right, let's go out and find a big bright star. This one's got to have an association. That is Alkaid. Okay, never heard of that star. All right, so you can search around the night sky. You can zoom in on the night sky. You can see all pixels in the images. And these images are not just from Hubble. Where would you, if you wanted to see just the Hubble images, you would go up to this Explore button. And here are whole collections of images that you can explore. We're from Hubble, so let's go to the Hubble images. Click on that, and you can see there are 12 pages of it. Again, zoom out and say, OK, here are all the Hubble images. There's still 2 different pages of it. All right, let's find a cool image from Hubble that things. Denise, you got a favorite one here? The Cartwheel Galaxy, one of my favorites. All right. All those gorgeous Hubble images that you remember from all our press releases. We have on order 100 of them here. We would like to have more. We need more interns to help do all the data tagging to get them there. All right. So here you have the Cartwheel Galaxy. And if I use the image crossfade, what does it look like in the digitized sky survey? Actually not that bad. The Hubble image is more detailed, pops more, but it's still apparent in the digitized sky survey in that trillion pixel thing. All right, Hubble isn't the only collection of images. There's also Spitzer Space Telescope. There is also Chandra Space Telescope, as you might expect. All 3 of NASA's great observatories that are still operating are providing details to it. But there are things, radio studies, NOAO, National Optical Astronomy Observatory, Gemini Telescope. They've got cataloged Messier objects, and then they've got some solar system stuff I'll talk about a little bit later. The one I really want to show you right now is the All Sky Surveys. Okay, and I'm going to back off so that you can see a wide field of view. All right, and let's see where let's go find the Milky Way. All right, and where do I want to go? I want to go this way along the Milky Way. Oops, other way along the Milky Way. Take that back, because the galactic center is kind of cool in a variety of things. How can you recognize the galactic center? You see this teapot shape over here? That's the constellation of Sagittarius. Okay, the teapot spout points approximately towards the galactic center. All right, I'm out at a 60-degree field of view. If I go from the digitized sky survey, if I say, OK, what does this look like in the dust map? Ooh, we can see where the dust is in the galaxy. All right. All right, if I want to go to infrared, the WISE view, the WISE satellite, it's their view. You can see they don't have incredible resolution yet on that, but it's getting better. Here we go, we're downloading more. I love the live updates as it's going through here. And that's the cool thing about it being an internet-connected application. When new data sets are available, you don't have to download them. Jonathan Fay and his team at Microsoft put them in there. Your software automatically just goes and finds them. Here's an infrared view of the night sky. Ah, cool. Shows you the real thin dust plane there. We can go to the 2-mass imagery. All right, this is another near-infrared view of the night sky. This is the 2-mass catalog of point sources. Oh, this one's fun. I'm going to click on this one. This is hydrogen alpha. Okay, so the hot bubbles of gas in our galaxy show up in hydrogen alpha. And you see all these sort of circularly shaped things. These are the hot bubbles of gas that are around 33,000 degrees Kelvin, where stars are forming. Ooh, what's this? This is kind of cool. Anybody recognize this? This is Barnard's Loop. Okay, what is Barnard's Loop? Barnard's Loop is, oh, we can't do the image crossfade here. If I go back to the digitized size survey, That is the gas around the Orion Nebula, okay? Kind of cool. There's a huge loop of hot hydrogen gas in the Orion region. You could also zoom in on all of these. They do not have a trillion pixels like the Digitized Sky Survey does. I'm sorry. All right, but when you zoom in, you can see that there is what it looks like in visible. Here's what it looks like in hydrogen alpha. If I bring this down here, you have a whole bunch of variety of things. You even have, what does the Orion Nebula look like in gamma rays? All right, not terribly exciting, but you know, there are a variety of ways to view the night sky. Okay, again, an incredible resource for doing multi-wavelength astronomy. All right, now where are we going to go with this? We've done the Explore. You can see that there are a bunch of other things. I should show you all the variety of things. Yeah, we'll get to those in just a second. All right, so we can also change the background of the night sky, not just by doing an overlay in the Owl Sky surveys. This is what this imagery button down here. All of those same night skies are available here. Okay, so we can do crossfades between various ones using this crossfade button down here. Okay, I don't have the crossfade working set up just yet, but I can change things down here and crossfade back and forth between them. Let me get back to the Digitized Sky Survey. All right, for that. Now, let's see. We've done the search. We should go to the guided tours, okay? Next thing that we're going to go to is how to get your students to do this same sort of thing and make it look interesting. All right, if you want to learn, you click on guided tours. All right, most people, when presented with the night sky, won't know where to go, okay? You all don't know of Camelopardalis, right? Your students won't know of Camelopardalis. If you would, so there have tours which look a lot like PowerPoint presentations, but PowerPoint in a multimedia fashion. All right, so the first set of tours are Learning Worldwide Telescope. And again, when new tours are created, they automatically show up in your software. You don't have to download them. They are there. Okay, and so there are a variety of tours. Here's a tour for educators, interactive tours, how to use the overview, how to create a tour, how to use the observing time, so on and so forth, okay? Various things for Learning Worldwide Telescope, but if you want to actually learn about the night sky, here is a set of nebula tours. This, for example, is one that I created on the Orion Nebula, all right? And if you want to watch it, you can push this blue button right here and say, okay, show me the Orion Nebula tour, okay? There is sound going on here, but it's not going to come out because I don't have a microphone to pull it out. And if I were playing this, you'd hear me talking along this. I also put the text on screen. Oops, get that out of there. Okay, so it goes over to the constellation of Orion. I do an overlay of Hevelius's drawing of Orion and describe what it looks like. The tour goes into Orion and says, okay, here Orion is very recognizable. You can see its X-shaped pattern. You can put overlays like this to identify the stars of the belt, Alnitak, Alnilam, and Mintaka. And then here's the sword, and we can zoom in using that zoom, all right, and start talking about these things. And if I say, hey, hold on. I want to pause this. Let's pause this tour. I bring the mouse up to the upper part of the screen. I hit the pause button. And then I say, oh, this is cool. I can zoom around and explore. And I can say, what is this star here? This is a really bright star. All right. Oh, okay. That's Nair al-Saif, also known as Sigma Orionis, I believe. All right. We can zoom in on it and explore and say, oh, these are fun things. And then when I want to go back to the tour, I go back up and I hit play. And it picks up right where I left off. One of the cool things about the tours is that it does allow you that exploration mode in the middle of a tour. All right. I'm going to pause it here again. All right. And I'm going to show you that what we've got here are these different slides here of where I'm going in the tour. And my tour is pretty long, and you can see there's a lot of these slides, but it looks very much like a stack of PowerPoint slides, doesn't it? All right, and if I want to say, oh, let's go look at those proplids, I can jump to this spot in the tour by double-clicking on it, and I move to that spot in the tour. You can see that there is a timing here. All right, this one lasts for 6 seconds for whatever I say during that presentation of the zoom in. All right, I can overlay images as I've got in this one here. So if I hit the play from this part of the tour, all right, you can see the images overlaid that you can bring in, the graphics you can come in. You can add music, you can add narration, zooming in onto things. You don't have to do the zooms. You actually just set the start point and the end point for the slide. It will do the automatic zooming in and out for you. All right. It's a very straightforward way to create things. Students can create their own ones, okay, and go through it and describe for you. So after your students have learned to use Worldwide Telescope, they can learn about one particular object, make a tour about it, and present it to the class. Then they go and they can save their tours. They can go up to the guided tours and do Save Tour As. It will save it as a WTT file, which you can take from their computer to your computer to any computer in the world that has Worldwide Telescope on it and play their tour on your computer. Okay? These are distributable, easily distributable. All right, I'm going to get out of the Orion Nebula tour. I will just show you that there are tons of nebula tours. There are galaxy tours, survey tours, planets tours, cosmology tours, black holes, supernovae, star clusters, cosmic events, educator stuff, and Mars and other and so on and so forth. I guess a variety of tours for you to take a look at. Okay? Let me back out of this so we can actually see where we are on all this. The tour infrastructure, why am I full screen mode? All right, I went into full screen. What is the full? There we go. Now I'm out of full screen mode. Great. It jumps into full screen mode for the tours, and sometimes you have to hit the escape button in order to get it back out of full screen mode, as you can see. All right, so there are these tours. All right, the other cool thing you can do with the Worldwide Telescope is go to this View menu. All right, and for this View menu, I want to go Search, and I want to go over to Jupiter. All right, click on Jupiter. Let's go see where Jupiter is in the sky right now. Aha, there's Jupiter in the constellation of Sagittarius. Now, did you notice what you saw as we zoomed in? You didn't see just one dot. You saw Jupiter and the 4 Galilean moons here. All right? Cool thing about this is if I hit the View menu, it has the observing time, which defaults to the current time. I can take that and I can speed it up. Now we're going times 10, times 100, times 1,000. We're following Jupiter around the sky. We're also, if I hit 10,000, following the Galilean moons of Jupiter as they go past. Notice when they come in front, you'll see the shadow right there. You can see the shadow of, I believe this is Io. No, this is Europa. And there's the shadow of Europa put on the disk of Jupiter. Okay? You can go through, and let me hit the pause button here. You can take the observing time, take it back to 1610, January 1610. You can recreate the observations of Galileo as he put into his treatise in 1610. Okay? You can have your students reproduce Galileo's observations and the deduction of the moons moving around Jupiter. You can follow it. The integrator here is scientifically accurate, plus or minus several thousand years. You can go back in time about 4,000 or 5,000 years. You can go forward in time about 4,000 or 5,000 years and get things accurate. Okay, I'm going to say okay on that. We can follow things. If I back off and I set time going really, you can watch Jupiter as it moves around the night sky, okay, over the course of days. And you'll see it do retrograde motion. Oh no, it's going backwards. Okay, eventually it will pause and it will go forward again. All right? It's also fun to see the geographic search go crazy down here as you spin around the sky like this. I'm going to take this down and get it out of the way. All right? There's the sun going past, okay? All right, so you can do all sorts of things in terms of that. If I happen to know the date of a total solar eclipse, I can watch the moon pass in front of the sun in Worldwide Telescope. In that PDF manual that I created on the VAO web page, I do give you the time, the coordinates, the place, and the time that you should set things in order to see the total solar eclipse. You said place, Frank. You didn't mention there was a place thing. Oh, yes, there is, because this is the observing time. This is your observing location. So I can hit the setup and say, oh, I want to see what the sky looks like from, what is this, Kabul, Afghanistan. Okay, we can click there. All right, and it's the same night sky until I click view from this location. And right now you see that, oh, all right, there is the horizon as the night sky looks in Kabul, Afghanistan. Okay? And so in the southeast, we have, what constellation is this? This is Canis Major. So this is Sirius. Sirius is rising in the southeast if you were in Afghanistan right now. Kind of cool. All right? But that is really important if you are going on, say, a cruise to Tahiti and you want to know what the night sky is going to look like in Tahiti. You can find it through here. Matter of fact, if you want to plan your observing session, even if it's only in your backyard, you can not only set your observing location, you can also set your telescope, because this has telescope controls built into Worldwide Telescope. For anybody who's an amateur astronomer, you can tell it what telescope you've got. You can use this ASCOM connection device and control your telescope. You can go into your view menu and say, all right, I want to show what my telescope will see. I have a Celestron Astromaster, and I'm using the Next Image Solar System Imager, all right? And I want to show that field of view indicator. Well, for that setup of that telescope with that imager, this is the field of view that you have in the night sky. So, I don't know, if I were trying to take a picture of this nebula over here, all right, I could zoom in and say, this is the picture I could get. That's as wide a field of view as I'm going to get with that telescope. And then you could say, hey, wait a minute, if I were, I don't know, let's say I worked at the Space Telescope Science Institute and I was using the Hubble Space Telescope, and my camera was also made by STSCI, and it's wide field planetary camera too, well then I would be able to see this field of view on the night sky. So if I were taking a picture with Hubble, I might want to organize it like that. And this is wide field planetary camera 2, their viewpoint on the night sky. And just you can set your entire observing session based upon things like that, okay? Cool little features thrown in. I'm going to turn off that field of view indicator, which takes me over to this overlay menu. Okay, you can have also a crosshair if you want to know what's at the center of your image. I tend not to use that. But one thing that's also useful when you're zoomed out is showing up the equatorial grid. So you know where you are in the night sky, going up to the North Pole and all the way down to the South Pole. You can see that for the solar system, we have the constellation, the orbits of the planets turned on. I can turn that off. I can turn the planets off. The planets have various lighting. I'm going to kill these guys for a second. I'm going to. All right, you can turn off the constellation figures, get rid of the focused one, get rid of the boundaries, get rid of the figures, and have a cleaner night sky, etc., and turn most of these things off, okay? I like having the figures and the night sky turned on. All right, now how much would you pay? Still $0 for this. Let's see, anything else in the view menu that's kind of cool? Oh yeah, the other cool thing about the view menu is that they have stereo if you want anaglyph or side by side or other things you want to do stereo 3D. He has stereo 3D in it for the things. It has a full dome mode for planetariums, and when you get totally lost on the night sky, you just come here and hit reset camera, and it takes you back to 00 in right essential and declination. All right, let's take off the equatorial grid there. And beautiful. Now, we have only been looking at the sky. We've only using one piece of this. All right? There are other things. This is the look at menu has been on sky the entire time. If I go differently, we can look at Earth, which brings up a totally different mode, which has Earth on it. Okay? And then you can, of course, zoom in and out on Earth. I know, I usually go, hey, let's go take a look at Goddard. Let's have some fun instead. Let's go over here. Oh, anybody recognize what we're zooming in on? This is the Grand Canyon, okay? We're zooming in on the Grand Canyon. All right, I gotta let it download because it's taking some time. All right, and notice it changes various data sets as we come down. All right, we're zooming in. Let it go out a little bit. If I come in, you can see all sorts of details. One thing you can't do with things is you can actually see the 3D terrain. Okay, where there is 3D terrain, Worldwide Telescope will show you that 3D terrain of the Grand Canyon. Isn't that cool? All right. Your house will be flat, sorry. They don't have 3D terrain down at that level. They're using geologic terrain, okay? This is why I go to the Grand Canyon or I try and find Mount Everest, because then you can see the 3D terrain. You're not going to see it at your house, all right? And then you can zoom back out into space. Otherwise, this is very much like you do with Google Maps in order to figure out how you're going to get to Goddard Space Flight Center at 7 in the morning. Okay, it has the Virtual Earth aerial, it has street maps. If you want to do that, that's all thing. But what's cool, actually, I like, is the Earth at night. This is the Earth at night image. So you can scroll around the planet and see where the lights are located, how few lights there are in Africa, how many lights there are in Europe. And this is a limited resolution image, but you can zoom in a little bit to see Paris here. Okay, yeah, that island of lights is Paris. Okay, I don't know, it looks like it's downloading here, so it has maybe a little bit more resolution, but this image doesn't have that much resolution to begin with. But you can see London over here. You can see the great metropolitan centers of the world are pretty darn obvious. Okay, the Northeast Corridor from Boston down to Washington. Yeah, we're getting our megalopolis standard there. All right. If we can do it for Earth, that's kind of cool, but that's something you can get on the internet in a bunch of places. What about the planets? You can do multiple other planets. Okay, the first one that they start with here is Mars. Anybody know what this object is? Olympus Mons, Mount Olympus, the largest volcano in the solar system. Okay, it is a shield volcano, so when we took it side by side, it doesn't look that huge. But recognize that it is 10 times taller than Mount Everest, okay? And it's incredibly wide. The size of this is the size of the entire state of Arizona, all right? The other cool feature that I like to do on Mars is, of course, Valles Marineris. We went to the Grand Canyon on Earth. Valles Marineris is about 100 times longer than Valles Marineris and 10 times deeper. Well, Valles Marineris is 100 times longer and 10 times deeper than the Grand Canyon. And you can spin around and take a look at Mars. It'd be nice if you could, they could download the Mars Global Surveyor stuff and patch that on here. They haven't got that. That's something they would like to be able to do. But if they had that, you could go down and find the rover tracks on Mars around Victoria Crater and other things. Mars is the most interesting planet to do that for. They have, where are the other planets? I'm sorry. They have Venus, the Moon, Jupiter. I wonder what they've got for the Great Red Spot on Jupiter. Do they just have a single map? Yeah, they just have single maps. So Nothing particularly fascinating to look at on Jupiter and other things, but they're there for completeness. But they also have things like Io, which is the volcanic moon of Jupiter. So some of the larger moons, mostly just the Galilean moons if I remember correctly, are done here, and you can explore them, their surface maps. All right. They also have a set of panoramas. These panoramas are 360-degree views. This one is from the Apollo 12 landing site. So you can see the magnificent desolation out on the moon. Okay, you can also zoom in. Let's find something interesting to zoom in on. Let's take a look and see that flag over here. Okay, and again, it will download all the pixels necessary and zoom in as necessary. You can see the footprints, okay, of the astronauts. And remember, I want you all to remember that there is no atmosphere on the moon. There is no rain on the moon. There is very, very, very little erosion on the moon. Those footprints are still there and will be there for billions of years. Okay, when they say, take only memories, leave only footprints, we left our footprints there and they're not going to go away anytime soon. All right, we can also go to a bunch of panoramas on the Mars. Oh, here's a cute one. This is the Many Rovers panorama. It's a panorama made up of a bunch of shots as the rover went around the landing site, exploring things. And of course, we have the what they call Twin Peaks in the background there. You can zoom in on these Mars rocks and say, oh, look, another Mars rock. How exciting! Because that's basically what every Mars press release says. Look, we found another rock, and there's chances that there might have been water. Just variations of that, and you've got all your press releases from Mars. I think this one here, yes, this one shows them drilling into one of the rocks to try and find such evidence of water and possible past life on Mars. A variety of panoramas. If I go here and show you, there are just tons and tons, especially from Spirit and Opportunity. So if you want to see all of the amazing stuff from them. Oh, the Phoenix landing site. This one's really cool because it has actual science inherent in the image. You can see at the Phoenix landing site where the Phoenix rover dug into the Martian soil. That white stuff there is the first evidence of subsurface ice on Mars. Okay? This is, the panorama. That ice did not stay there. It evaporated over the course of several days and is no longer there. But when the first Phoenix lander dug in, we found evidence, the first evidence of ice in the subsurface of Mars. All right. Final feature that we're looking at here will be the solar system. And now we move from the standard looking at the night sky in 2D and now we're looking at the night sky in 3D. Okay, you can't tell because I've turned off the orbits, but here are the orbits of the planets and Pluto. And if you rotate them and look at things edge on, you can play Sesame Street. One of these things is not like the other. Which one is it? Okay, it is, of course, Pluto's orbit doesn't match the rest of the eight planets, and this is part of the reason why it was declassified. But you can see the orbits of the inner planets, and the orbits of the outer planets, and you say, well, wait a minute, I can't even see the planets. Well, that's because the planet size has been reduced to their actual size. When you look at the solar system in true scale, the planets are impossible to see. So we have a slider down here where you can make them larger. Okay, and then as I zoom in, all right, I can start to see the planets relative to the scale that I'm looking at. And so there is Saturn, or this should be Saturn, this should be Jupiter here. I've got the lighting on. If I take the lighting off, can I see them better? Yeah, there we go. I'll take the lighting off, I can see them better. And you can see that down here, I could just click on Earth. It will take me to Earth, generally flying through the sun. Ouch, that hurts. All right, and there is Earth, nice and big. All right, in the next version of Worldwide Telescope, that Earth view that I showed you previously will happen here, and then you can continue in and zoom down to your house in the 3D one. He hasn't got that in the current version. All right, I just talked to Jonathan last weekend at a conference in California. All right, and so you can scroll around, and this is great for using this observing time thing. Okay, to watch things like the moon orbiting around Earth and teaching basic celestial mechanics in terms of the phases of the moon, eclipses of the sun, eclipses of the moon. All right, you are following Earth in its orbit. Again, you can take them down to be their actual size, in which case it's much, much harder to see. Okay, but you can also bring it up to being larger, where your kids can actually understand what they're doing. Again, if they have Windows, they can make tours of the 3D solar system. If they only have a Macintosh, they can't use the 3D solar system at all. I'm sorry. The 3D graphics libraries for Silverlight are not available. The programmers didn't put them in, so he can't. Jonathan keeps bitching that he can't get the 3D part into the Macintosh version of it, because even though he works for Microsoft, he's all about making things available to everybody. All right, I'm going to turn time up even faster. And here you see the planets start to orbit around. I'm going to actually center on the sun. All right, and okay, you can see the sun doing its thing. I'm going to pull up so you can see the orbits of the inner planets. I'm going to take the time going faster one more. You can see the Keplerian motion of the planets, that the Mercury goes around much faster than Venus, which goes around faster than Earth and Mars and then Jupiter. Pull out. You can see in comparison, these guys are moving like speed demons, and everybody in the outer solar system doesn't look like they're doing anything. We can make the inner solar system go crazy by going another faster. Ah! Help! Stop the world! I want to get off! Okay. At this point, even Neptune looks like it's moving around the sun at a decent speed. Okay. So then you can drop that back down, play with your observing times. All right. You can do all sorts of things exploring the solar system here. But is the solar system it? No. You can pull back and pull back and pull back, and whoops, there goes the sun. Goodbye, sun. Oh, wait a minute. There go the stars. All right. You have a 3D stellar system as well as a 3D solar system. You can spin around, look through all the various stars. There is a way to fly between the stars, but I clicked on that star. I don't know what it took as the center point. We pull back. You can see this is the Hipparcos star catalog. I can pull back, and you can see the Hipparcos star catalog as just this cloud of stars. How big is that cloud of stars? This is 100,000 stars in the night sky. More stars than you can see with the human eye. The human eye can only see about 10,000 stars at night. This is 100,000 stars. Well, the size of it, if I turn on the Milky Way, is about the size of a pepperoni on a large, extra large pizza, because this is the scale of the Milky Way. These are all the stars in the Hipparcos catalog compared to our Milky Way. All right, let me just rotate it so you can see. All right, this is a drawing of the Milky Way done by Robert Hurt at the Spitzer Science Center. And I can turn on the cosmos, which are these galaxies in the Sloan Digital Sky Survey, and pull back from our Milky Way, and then fly amongst the various galaxies out in SDSS. Okay? It is not a complete all-sky map of galaxies by any means. If I pull out a little further, you can see the shape of the Sloan Digital Sky Survey. But there are approximately 200,000 galaxies that one can look at in this in the Sloan Digital Sky Survey, and spin around and see, oh, cool, we got some galaxies that we want to go and take a look at. And here you are, not flying amongst stars, but instead flying amongst galaxies and seeing all the galaxies go past you in the universe. All right, if I double click on the sun, I can say, take me back home. Oops, oh, I should have just hit the all right, well, I should have single clicked it instead of double clicking. Double clicking got me there immediately. Single clicking would have done the full animation of flying back down through the galaxies, through the Milky Way, through the stars, down to the solar system. But I apologize. The cool thing about all this is that, of course, that the motion is geared to the size that you're viewing on screen. So when you're in the solar system and you're using your scroll wheel like I'm doing now, you're moving relatively slowly. Once the size, scale, distance from the sun gets much larger, you start moving proportionately faster and faster and faster, so that you then can move amongst the stars in a smooth fashion. The stars start moving, the galaxies start moving, the cosmos starts moving, and so on and so forth. All right, now if I go from here and I do a single, I can zoom back in. Oh, the one other thing I will show you, and it's relevant to one of the talks I'll give this afternoon. All right, my computer seems to be going slowly. All right. One last thing that I always hesitate to turn on because it totally blows my computer. My computer's going slowly enough as it is. There we go. Now we're stopped. All right, let me pull back out to get to the right view. Okay, my laptop doesn't like this, but if you see this asteroids button here that I haven't clicked, well, if I hit the asteroids button, up will pop about 400,000 asteroids. Okay, I'm going to turn off the cosmos and the Milky Way. All right, these are all the asteroids, and the main belt asteroids, the Trojan asteroids around Jupiter, and so on and so forth. If you've got a really good graphics card, which my laptop doesn't have, you can actually explore the orbits of the asteroids. I think it's great for showing the asteroid belt. It also includes in it, although they're not technically called asteroids, it shows you the orbits of the Kuiper belt out here, the icy object outside the orbit of Neptune that includes this thing here called Pluto. All right, on that. Brandon, anything I've forgotten?
Just a reminder that not only does the solar system not work with math of the course.
Tour creation. Okay, so the caveats. It is from Microsoft Research. It is free, but it runs best on Windows. The 3D stuff does not run on the Silverlight client, and you cannot create tours in the Silverlight client. You can watch tours in the Silverlight client as long as they don't go into 3D mode. Okay, any tour that doesn't go into 3D mode, you can watch in the Silverlight client, but you cannot create tours in the Silverlight client.
And you also have on the DAO website some activities that they can explore.
Right. I showed them that at the beginning. Okay. The last thing is that they have these communities that you can join. I haven't bothered to join any communities, but if you want to, in your high school, create a community, you can form a community. Your students can join that community. They can share their tours through that community. I personally have not played with the community feature very much, just to know that it exists, and should we want to develop an OPO community where we can share all our tours out with everybody in the world, we could do so. We have not chosen to do so. So that is Microsoft's Worldwide Telescope, a cool piece of software that you may be able to use in your education.